Alright, let's use what we've just learned and see if it helps or not. Find the formula for the nth term when the common difference is 3 and the first term is 2. This is for an arithmetic sequence. So let's build our sequence. Well, the first term is given, 2. So the common difference is 3. So what will the next term be? We always add the same number, the common difference, over and over. So 2 plus 3 plus 3 plus 3, etc. But now I want the nth term, and you might just look at it and recognize the pattern. What will I do for time? What would I do with the 1 to get a 2, the 2 to get a 5, the 3 to get an 8? And that's about all we had to go on earlier. But when it's an arithmetic sequence, we actually have a formula to help us get the nth term. And it's always going to be a sub 1. A sub n is a sub 1 plus n minus 1 times d. So when I have that, I'm good to go. So in this case, the nth term is a sub n. That's what I'm looking for. A sub 1 we know is 2 in this case, plus n remains n because that will be in my generator or nth term, and the common difference is 3. So let's distribute the 3 and combine like terms. I get 3n minus 3, or negative 1 plus 3n, and I'll write it more aesthetically pleasing, 3n minus 1. So, is that the nth term? Let's go back up and see if it works. So when I put in a 1, do I get a 2? When I put in a 2, do I get a 5? When I put in a 3, do I get an 8? I do, I do, I do. Alright, again, I'll just show you another example or two just to show you all the different problems. This is sort of, you can come at so many different angles, so I'll just show you a few, and from those you can you should be set to be poised or set to answer any question that I might come up with. So say this is given. The fourth term in the arithmetic sequence is 20 and the 13th is 65. So I want you to write the first 5 terms of this arithmetic sequence. Write the first 5 terms. So in order to do that, we need the first term. We need to know what the first term is and the common difference, so we can get from the first term to the second and third, fourth, fifth. So let's take from our information here everything that we can glean. So let's say I'm going to put down my formula. A sub n equals a sub 1 plus n minus 1 times d. Right, that's the formula for the nth term. But it's also the formula for the 4th term or the 13th term. So I'm going to take this information and feed it into here and see what happens. So a sub 4, so that means our n is 4, we know it's 20. So a sub 4 is 20. A sub 1 I still don't know. N I do know because this is the n. 4 minus 1, and we don't know the common difference. So we have 20 equals a sub 1 plus 3d. So that's about all we can get out of that. So now let's bleed or glean this one. And we're going to start with the formula again. Alright, see if you can do this one without blab from me. Oops, that's supposed to be a minus. Sorry. Did you notice that? 2 hands up. Alright. 13 minus 1 times d. So I end up 65 equals a sub 1 plus 12d. Alright. So I have this equation that is true and this one is true. I need these 2 parameters to complete my command. So guess what I'm going to do? All right, this keeps coming up over and over. So we should be good at recognizing when there's two equations with two unknowns, we're going to solve them simultaneously. These always work out well because the a sub 1's are lined up to cancel out. So I'm going to change the signs on the ones on the bottom by multiplying through by -1 and then adding these. So 65 and -20 gives me 45. The a sub 1's are gone, and that equals 9d, or if I divide both sides by 9, I find out that d is 5. So now I need to know what a sub 1 is. So I can put it back in any of these. This one's kind of handy, so I'll just put it back in there. So I get 20 equals a sub 1 plus 3 times 5, or a sub 1 equals 5. All right, so we are, that's kind of interesting. A sub 1 and was 5, and so was the common difference. All right, so a sub 1 is our first term. How do we get from our first to the second? We add the common difference. Add the common difference, and so on. So I generated the first 5 terms. There are other ways to think of that, and if you have those, you can probably try your own method and see if it works. Alright, like I said, I could show you a bunch of different examples, but in the end, you end up using this formula, so I'm just going to let that go at that point and show you one more thing that takes another twist. Alright, we'll end today by looking at an arithmetic sequence. Say we have 1, 3, 5, 7, 9. Alright, say that's the sequence that we have. When these commas blow up and become plus signs, alright, so now the commas are gone and they've turned into plus signs. I no longer have a sequence, I have a series. So a series is when we take ordered numbers in a sequence and add them. We're going to look at that now, and let's see what else. Hold on a second. I don't know if I can jump right into where I was headed or not. Don't want to skip anything. I guess I can. Let me see. Alright, I'm just going to do it. If there's a hole in my teaching, it'll show up in our work tomorrow and I'll be there to plug it in, right? Alright, so what I'm going to do now is I'm going to take a sequence and turn it into a series. And I want to know the sum of a finite series. And I'm going to develop a formula for that, and I'll do it by example. Suppose the first term in my sequence, which is now going to become a series, is 3, and then 7, 11, 15, 19, 23, 27, and 31. So, can you see what the common difference is? So, we're going to add these, and it's now a series. And of course you could plug these into your calculator and find it very quickly when it's small, but I could make it 200 long, and that's where you would need this formula. So I want you to note that to find the sum of a finite series, that means it has an end, I want to see in this case, what's the sum of the first and the last numbers? 34. What's the sum of the second and the second to the last? 34. What's the sum of 11 and 23? I remember when I was growing up, my mom, when she saw something beautiful, she would go, and it was always scared me. I was driving around somewhere or walking, and she'd go, And it was just something beautiful, like a sunset or a flower or something. Well, here's something beautiful. So we have the same number 4 times, and there were 5, 6, 7, 8 numbers in this problem, but there were 4 times that I used the 34. So it's going to be 34 times 4 to come up with the sum, and that will be what, 136. All right, is that right? Yeah, I guess so, 136. So let's put that in a general statement. The sum of n numbers in an arithmetic sequence, that's how I'm going to symbolize that, is the total number, there were 8 here, divided in half because we had this pairing. And what will we multiply that by? Well, we could say, well, it's the third number and 3 from the end, or we could say the second number and 2 from the end, but the easiest to put in the formula will be the first and the last. So that's what I'm going to say, the first and the last. This is the formula for the sum of n numbers in an arithmetic series. So let's test it out. Let's say that I want to add all the numbers from 1 to 100. I've been wondering about that. What do all the numbers from 1 to 100 add up to? So I'm going to add 1 plus 2 plus 3 plus 4 plus 5, etc. until I reach 100. Well, according to this, the sum of the first 100 numbers is going to be, we're going to pair them off, so we're going to take 100 and divide it by 2, and it would be the first number 1 plus the last number 100. So I followed this pattern, and I'm going to get 50 times 101, which turns out to be 5,050. So that's pretty cool. Alright, I think that's enough for tonight, and we bit off a lot on the sequence and series, so hopefully you got it all down, and maybe I'll even check it tomorrow. Alright, I'll see you then. Good night.